far beyond Neptune, in a region so dark and distant that sunlight feels like a fading memory. Something is quietly pulling on our solar system. Not a comet, not a known planet, but something we can't see. And yet, we know it's there, because of the footprints it leaves behind. A cluster of icy worlds, drifting over 10 billion miles from the Sun, are all leaning, tilted, moving in the same strange direction. It's like watching a group of dancers spinning in perfect sync, around a partner that simply isn't visible. So the question is, are we looking at a coincidence, a flaw in our data, or the gravitational signature of a hidden planet, possibly one that doesn't even belong to our solar system? Let's break this down, because what scientists are uncovering could completely rewrite what we think we know about how our solar system formed. Out in the frozen outskirts beyond Neptune lies a region called the Kuiper Belt. This is a vast, donut-shaped field of icy debris, leftovers from the early solar system. Most objects here follow a predictable pattern. Their orbits sit roughly along the same flat plane as the planets. Slightly messy, yes, but still organized. But then, things start to get weird. Astronomers began noticing a group of objects, far more distant than the rest, orbiting between roughly 80 and 200 astronomical units from the Sun. For context, 1 astronomical unit is the distance between Earth and the Sun. So we're talking about objects up to 200 times farther out than Earth. And these objects refuse to behave normally. Instead of orbiting along the expected flat plane, they're all tilted by about 15 degrees in the same direction. Not randomly scattered, not chaotic, but aligned, coordinated, almost intentional. Now, one odd orbit, that's easy to dismiss, but a whole group, all leaning together, that's where things stop being coincidence and start becoming a mystery. Because according to everything we know about solar system dynamics, this pattern shouldn't exist. Over billions of years, the massive gravitational forces of Jupiter, Saturn, Uranus, and Neptune should have scrambled these orbits, smoothing out any alignment. Patterns like this are supposed to disappear over time, not stay locked in place. So naturally, scientists asked the obvious question, is this real, or are we being tricked? To find out, researchers ran thousands of simulations, recreating the outer solar system again and again. They tested random orbital distributions, accounted for observational bias, and included the gravitational effects of all known planets. And the result? None of those scenarios could reliably reproduce what we're seeing. The alignment just wouldn't happen on its own. But then, they added one more variable, a small, unseen planet. And suddenly, everything changed. With the gravity of this hypothetical planet included in the models, the simulated orbits began to line up, almost perfectly, matching the real observations. The distant objects started behaving exactly like the ones we see through telescopes, gently guided into that shared tilt. This invisible object has been nicknamed Planet Y, and while no one has actually seen it yet, its presence might already be written into the motion of these distant worlds. Now here's where it gets even more interesting. If Planet Y is real, it doesn't just add a new member to our solar system. It completely challenges how we think planets form in the first place. According to standard models, rocky planets like Earth form close to the Sun, where material is dense and collisions are frequent. Out beyond the gas giants, the building blocks are sparse, too thinly spread to easily form Earth-sized worlds. That's why the outer solar system is filled with icy leftovers, not solid planets. So finding a rocky planet sitting more than 100 astronomical units away? That shouldn't happen, which leaves us with two possibilities. The first, is exile. Planet Y may have formed closer to the Sun, billions of years ago, during a chaotic period when the giant planets were shifting positions. During this time, gravitational interactions could have flung smaller planets outward, ejecting them into distant, elongated orbits. In this scenario, Planet Y is a survivor, a relic of that violent past, stranded on the edge of the solar system. But there's another possibility, one that sounds almost like science fiction: capture. The Milky Way is believed to be filled with rogue planets, worlds that drift freely through space after being ejected from their original systems. Some estimates suggest there could be billions of them, wandering in the dark between stars. And under the right conditions, a star like our Sun could capture one. If a rogue planet passed close enough and at just the right speed, the Sun's gravity could pull it in, trapping it in a wide, tilted orbit. If that happened, Planet Y wouldn't just be another planet. It would be an interstellar visitor, a world that formed around a completely different star, before being stolen by ours. Now, before things get too wild, it's important to clarify something. Planet Y is not the same as the more famous Planet 9 hypothesis. Planet 9 proposes a much larger world, several times the mass of Earth, orbiting much farther out, to explain a different set of orbital patterns. Planet Y, on the other hand, is smaller, somewhere between the mass of Mercury and Earth, and it specifically explains the shared tilt of objects between 80 and 200 astronomical units. Two different mysteries, possibly two different planets, or maybe just different interpretations of incomplete data. And that's exactly where the skepticism comes in. Because as compelling as this evidence is, our map of the outer solar system is still incredibly limited. We've only observed a tiny fraction of what's actually out there, and where we choose to look can influence what we find. This is called observational bias, and it can create patterns that seem meaningful, even when they're not. In other words, it's possible that this alignment is just a statistical illusion, a coincidence, amplified by the gaps in our data. And until we physically see Planet Y, that possibility remains on the table. So how do we find something that far away? Well, it's not easy. At distances beyond 100 astronomical units, sunlight is incredibly weak. Any object out there would reflect very little light, making it extremely faint. If its surface is dark, which is common for outer solar system bodies, it becomes even harder to detect. And then there's motion. A planet that far from the Sun would move painfully slowly across the sky. It could take over 1,000 years to complete a single orbit. That means its movement is almost invisible, unless you observe it over long periods of time. So astronomers need a smarter strategy, not just looking for something bright, but searching for something that moves, even slightly. And that's where the Vera C. Rubin Observatory comes in, one of the most powerful survey tools ever built. It scans huge portions of the sky every few nights, creating a time lapse of the universe, capturing even the tiniest changes. By comparing images over days, weeks, and months, scientists can detect objects that shift position, even if they're incredibly faint. This method has already uncovered new asteroids, distant comets, and unknown objects at the edge of our solar system. If Planet Y is found, it could rewrite everything, revealing planetary migration, violent gravitational pasts, or even captured rogue worlds. But if it's not, the mystery deepens, because those tilted orbits are real, and something caused them. Either way, we're on the edge of discovery, and soon we may finally uncover what's hiding in the dark.